for joining. What we have today is a quick overview of UVC for HVAC systems. My name is Joe Kalman. I'm the Director of Sales for UV Resources and Sterile Air. And just want to cover a couple of quick housekeeping items. We're going to record the session and we'll share a copy with everybody. And feel free to post questions in the chat area, as Paul alluded to as he was kicking us off here. We'll try to address questions at the end of the presentation, and we're going to be brief. We're going to motor through this. We have less than 25 slides. It's going to give us some time to answer some questions at the end of our allocated 30 minutes. And bear with me, folks. I seem to have contracted a little bit of a cold here, so I may hit the cough button a couple of times, but I'll gut it out with you. So again, thanks for joining us. As we jump in, I want to give you a little bit of background on UVC for HVAC systems for some of the folks that may not be familiar with the technology. So just a quick overview. The ultraviolet germicidal wavelength is produced by the Earth's sun, and it's absorbed by our atmosphere. So what we mostly encounter as inhabitants of the Earth are the cousins of UVC, and those are UVA and UVB. And those are the wavelengths or the bands in the wavelengths that can cause sunburn. However, the UVC band in this electromagnetic wavelength damages a microbe's genetic code, and that's what prevents cells from reproducing. Thus, it effectively inactivates or kills the specific bacteria, fungi, and viruses. So with that little science lesson in the rearview mirror here, let's go ahead and turn our attention to the benefits of applying UVC to HVAC cooling coils. All right, I hope that everybody can still hear me here. Just let you take a look at that statement here on the screen here. Airflow levels increased by 43.7%, or roughly 6,000 CFM, nearly doubling cooling capacity and saving $70,000 a year in HVAC energy. And what if you could tell the C-suite that a project like this one with similar results that helped boost airflow levels and essentially doubled the cooling capacity and produced this huge gain in productivity, that you were able to reproduce this similar results in your facility? If you break it down by air handler, it's $8,000 per AHU. And if you magnify that savings across the number of air handlers in your building or in the proposed building, at this point, I think you should have everybody's attention in management. We're talking about a transformational level of change to both HVAC performance and a pretty substantial savings in energy. So just rolling through these benefits, and we're going to I'm going to reiterate these benefits a couple of times to really help you get comfortable with building this business case. But firstly, UV energy can reduce energy consumption and restore in air handlers heat transfer efficiency. Secondly, UVC improves air quality by inactivating bacteria and other airborne pathogens. Third, UVC maximizes heat transfer efficiency, and that's the ability of the air handler to remove heat and moisture from the air. And fourth, it lowers maintenance costs and eliminates the need for mechanical and chemical coil cleanings. But how does heat transfer efficiency relate to the C-suite, and why should management care? And again, this is building this business case that we talked about. So we're going to review how HVAC energy and how UVC are harnessed to restore cooling capacity, reduce energy use by up to 20%, and how it can improve indoor air quality and disinfect air streams. And so we're going to talk about ASHRAE and the ASHRAE standards and where UVC fits in to that environment. And we're going to talk about selling your solution to management. And I'm a sales guy, so that's kind of the place where I live, is the sales part. All right, so we've got a couple of pictures here, and apologies in advance for anybody that's snacking or eating lunch while they're going through this, because it's a little disgusting there. But these pictures are typical of what it looks like when you get inside an air handler. That biofilm that accumulates on the coil is just a byproduct of that condensation in that moist environment that is the cooling coil and that downstream side of the cooling coil in an air handler. And it is a magnet that attracts bacteria and dust and airborne particulates. And when you look at this cross section, the one on the right-hand side, you see that first row, that clean little stripe, the vertical clean stripe. That's typically what's produced when you pressure wash or chemically or mechanically clean a cooling coil. You can get that biofilm and that gunk off of the very outer surface, but the rest of that cooling coil still remains mucked up. And this is important for our conversation about UVC, because what happens when you do pressure wash is you push that organic matter that grows in that coil further and further into the coil, and it's reducing that air handler's ability to remove heat and to effectively condition the air. And UVC has got an answer for that scenario, and so we'll talk about that. All right, so without proper maintenance, evaporator coils can become fouled, and we saw that in those previous pictures. Biofilm, that collection of organic material that grows or festers in that air handler, it creates a barrier between the warm air and the coil. And as that coil becomes fouled, it's harder for the system to push air. And remember, when you've got that pressure drop, that takes more energy to move air through the air handler. And so we'll talk a little bit about that. All right, so we got some pictures here, and we got some small print. But if you look on the top left there, that is what it looks like in a new air handler. That's a new cleaning coil. Those are aluminum fins. Those are copper tubes that run throughout. And you typically have about a 500 feet per minute approach speed. And as that air travels through those fins in that cooling coil, in an optimal scenario, you're going to get about a 54-degree leaving air temperature. That WB stands for wet bulb. The lower left picture, you see when you add only a small amount of biofilm, 0.006 inches, which is basically the width of a piece of human hair, you see that same 500 feet per minute approaching airspeed. Those fins, they begin to close. And so that small amount of biofilm creates a scenario where the fins are only 51% open, and the resulting leaving air temperature is higher. It's 4 degrees higher in this scenario with only 0.006 inches of biofilm, 58 degrees. So that's pretty significant. So let's talk about the impacts of that here. Keep this conversation going. So what happens when you have that clogging or that buildup of biofilm? You've got to compensate for it. And in many cases, systems have VFDs that electronically make these compensations or alterations to the operation of the system behind the scenes. But basically what's happening in order to overcome that decline in heat transfer efficiencies, you got to speed up the fan. You've got to pump more chilled water, which increases the kilowatt per hour usage. And you've got to lower the water temps, which again puts more pressure and utilizes more energy. And as that system loses cooling capacity, this energy intensive cycle of adjustments continues to move along. And we call it the vicious cycle. You know, as that condensation attracts debris to those coil fins and provides food for that biofilm, and as that biofilm forms and continues to hinder that heat transfer, that increases that pressure drop. It requires more energy in the form of ramping up that fan, lowering the chiller temperature, pumping more chilled water. Again, a restricting of airflow and a cutting down of the efficiency of that system, and the cycle just keeps on playing out. All right, so looking beyond the performance improvements that UVC can provide by basically eliminating that biofilm and keeping that system running as it's as designed condition when it was newly commissioned, UVC adds additional benefits of providing healthier air into offices, classrooms, hotel lobbies, etc. Um, some facilities have two UVC systems, one for maintaining routine coil cleaning efficiency, and they've got a second set that they will deploy for flu season or when the additional airstream disinfection is needed. And as less energy is required to keep building occupants safe and comfortable, your building's carbon footprint decreases, fueling your organization's sustainability efforts. So we like to talk about the indoor air quality improvements that go along with this coil cleaning application of UVC is kind of a double-barreled solution. So this is just a graphic that recaps some of those benefits that I rattled off there and puts them in more of a concise form. But the benefits of indoor air quality are many. Improved cognitive function. Say that twice fast. Um, Decreased absenteeism, employee retention, improved morale. When people are happy and healthy, they're in better moods. Um, You've got the health symptoms, tiredness, loss of concentration, loss of control, depression, anxiety. They're all clinically proven to be effects of poor indoor air quality. Skin irritation, respiratory tract issues, asthma, allergies, infectious diseases, the cold and flu season, and even cancer linked to indoor air quality. Um, Again, the implementation of a UV system in the air handler is really going to help support improvements in all those areas that we just went through. Let's talk a little bit about ASHRAE because that's where our UVC technology is really rooted. We've got a slide here that talks about the engineering controls. When it comes to reducing infectious aerosols, ASHRAE recognizes three proven engineering controls, and that's ventilation and dilution, particle filtration or mechanical filtration, and germicidal UVC. And so all three of these, including UVC technology as the third, are extensively peer reviewed. This isn't new. This isn't a new gizmo that came about during the pandemic. It's been around for years and years, and it's extensively independently tested, peer reviewed, validated, and researched. So ASHRAE's position on UVC is first, chemical and mechanical cleaning is costly and really doesn't do anything to prevent future biological growth. And unlike mechanical cleanings, UVC works around the clock, 24/7, 365 to halt the growth of bacteria and mold. Again, the fundamentals of UVC in an HVAC system, it's keeping biological material from growing and being passed through that HVAC system. It's as simple as that. Germicidal energy improves cooling capacity by reducing pressure drop or resistance on pushing air through a fouled coil. And then finally, once the biofilm is eliminated, the heat transfer process becomes more efficient and less energy intensive. All right, so now to the good stuff, how to sell it to the management team or the folks that are holding the purse strings. This picture is one that came out of an ASHRAE funded study, which was commissioned to show the effectiveness of UVC, and it was conducted by Penn State researchers, and they found that UVC reduces the average pressure drop. Remember, we talked about that pressure drop and we talked about heat transfer, but UVC, as found in this ASHRAE field study, reduced the average pressure drop on the amount of energy needed to push air through the coil by 21%. So when that coil is cleaner and when it's running more efficiently, air passes through more easily. They also found that the heat transfer efficiency rate increased by 14%, allowing the air handler to draw out more heat. Excuse me. So UVC enables 14% more air volume to be efficiently cooled using 21% less energy. In other words, UVC increases an air handler's heat transfer efficiency by using less energy. And these two pictures really tell the story. That's a before and after of this ASHRAE field study. You can barely see the newly installed UV light being transmitted through that clogged cooling coil. And I think it was a period of 60 days. That's the after on the right, where you can see the UV light coming through those coils. So just the presence of that UV energy remediated that pretty nasty looking cooling coil. So this is another project, and it's a white paper that we make available. This is a project that we profiled at the very beginning. Remember that bold statement that I threw out there about the $70,000 annual energy savings? Well, this is where it came from. This is a project that produced a 43% increase in airflow, nearly doubling its cooling capacity. And this was in a Class A 12-story office complex down in Miami, Florida. So Jones Lang LaSalle, I don't know if we have any JLL people on this call, but they commissioned a third-party audit of the energy savings to document this turnaround. And in addition to the striking improvements that they delivered in HVAC performance, the addition of UVC also drove a huge capital savings, because they were scheduled to replace some of these air handlers. And instead of replacing these 16-year-old units, just the retrofitting of UVC restored the performance and kept the tenants of this building comfortable. And in fact, a decade later, as we sit here today, the same air handlers continue to deliver for that facility. And imagine, again, in the framework of selling this to holders of the purse string, imagine telling them that ownership, that you're able to extend equipment life with only a 15 cent per CFM retrofit solution. Pretty compelling stuff. So again, just back to those concepts that we introduced of lowering the pressure drop and improving the heat transfer. This is the actual source of that savings. You're lowering your fan brake horsepower. You're lowering pump brake horsepower, chiller output, cooling tower load reductions, system maintenance, and extending equipment life. So these are the tangible mechanical areas where UV delivers the ROI and improves the savings. So the eureka moment for management, we think, and from the many conversations I've had over these past couple of years selling this solution, is when you can explain that you can eliminate many of the energy intensive adjustments needed to compensate for a fouled HVAC system. And since HVAC represents a significant portion of a building's operating budget, even those smallest marginal improvements can translate to big savings. So overall, the average commercial electric utility rate in the country is about 13 cents per kilowatt hour. And you can see from the graphic, it's a lot higher in some corners of the country. But major metropolitan areas, whether it's Los Angeles, you could see it almost 24 cents. You imagine what delivering a 15-20% savings to the operating costs of their HVAC means to the bottom line in a facility in one of these high cost markets. You can take a 60 hertz fan down to 26 hertz across 30 air handling units. That's cutting HVAC usage in half. And you multiply that savings by over 30 or 40 air handlers in a large commercial building, you're really going to get the attention of management. And it becomes a very compelling story to sell. All right, we're coming to the end here. Just going to recap a couple of the key elements to making this sale. It's important to emphasize the benefits of investing in UVC. First, restoring air handlers to their original performance standards. That's a key here. Lowering operating and maintenance expenses with better heat transfer efficiency. There's no need for expensive coil cleanings. Fewer mechanical corrections, of speeding up fans and lowering chilled water temperature, all that stuff that we talked about. And I don't want to just blow by those air quality improvements and the positive ripple effect that they can have on building occupants. And unlike other air cleaning technologies, UVC inactivates airborne microbes without introducing any contaminants or altering the air chemically. We're not spraying anything in or adding ions or ozone. I think that's a key advantage. UVC is a subtractive technology as opposed to being an additive technology, as some of the other remedies out there are. So just to summarize, it's a very favorable time to make this pitch to employ UVC in HVAC systems. Public awareness of IAQ is at an all-time high after the pandemic. And the benefits are so great. It's amazing that there isn't stronger industry adoption. There are devout believers out there, but that's something that the reason that we're having this webinar today is to get more people familiar with the technology and the advantages. And every air handler is going to perform better and at less cost and yield healthier air with UVC. So you don't have to pick and choose and pick your spots. It's every air handler is going to benefit. So just real quick, for those of you that are familiar about UVC, thanks for sitting through that. For those of you that aren't, hopefully you picked up a couple of tidbits of knowledge there. SteriLair and UV Resources, our two brands, are the two pioneers who began UVC in the HVAC industry. We actually own the trademark for UVC for HVAC in the category. And together our two companies represent over 45 years of industry expertise, and we hold 17 UVC technical patents, and we're really the foundation of the HVAC ultraviolet industry, and we're extensively involved with ASHRAE and other industry associations. So as uncomfortable as it is to brag on yourself, I thought that bears mention there. All right, the last summary slide here. Again, just we talked about it. UVC helps reduce energy usage, boosts heat coil transfer efficiency, disinfects airstreams, and provides improved IAQ. That biggie of reducing maintenance cost and prolonging equipment life. It is a pretty compelling pitch, and hopefully you were able to get a couple of takeaways. I'll now turn it over back to Joel here. He's been monitoring the chat to see if we got some questions here.
Okay, terrific. Thanks, Joe. It looks like we've got a question here about the payback for a UVC system. What is the typical ROI?
Good question, Joel. There are a lot of variables. The largest of which is probably what the energy cost is for that particular geography, the air handlers, the age of the system. But typical users pay for their UVC system in less than 12 months. I know in Southern California, where you've got those 24 cents per kilowatt hour rates, we can deliver the payback in 4 months. And extremely fouled coils, older systems, you can get payback in any market in as short as 5 months. So we feel real comfortable with using that 15% savings, and that's going to get you to ROI within a year in almost every case.
Okay, it seems like cost is on everyone's mind. Our next question is, what is the cost of a UVC system? So maybe you can give us some context of how much a UVC system would require in terms of like an initial investment.
Yeah. Yeah, it's on everybody's mind. Great question. I was getting ready for that one. Yeah, I wouldn't be a good salesperson if I didn't talk about, throwing out, give us an opportunity to do a facility audit and give an accurate estimate. And that's something that we do all the time and that we're happy to do. But a rule of thumb is about 10 to 15 cents per CFM. So it's a pretty simple calculation. So a 20,000 CFM system, the installed cost, $3,000, and that would start paying for itself very quickly. Lamps, that's another question that we get. Joel, I don't know if anyone chimed in there. lamp replacement it's an annual event, roughly 3 cents per CFM. So it's a pretty cost-effective initiative to undertake for sure.
Yeah, I would say, considering that UVC energy will lower HVAC energy use, and like you said, improve air quality and lower maintenance costs. So 15 cents per CFM is a good rule of thumb. I like your thumb. Next, we have a question from Tim. He wants to know if he can stop pressure washing his coils twice a year by using UVC energy.
Yeah. I would say definitively yes, but I would also give a caveat that you have to make sure that you keep that drain pan and the drains clear, because as that UVC starts to do its work and starts to degrade the biological material, it will slough off just by virtue of the condensate, and it will clog up the drain pan with the green gunk pretty quickly. But if you keep the drains clear and you keep that flowing, you will eliminate all that biological material from that air handler, and you will not need to pressure wash.
Okay. Joe, there's a question from Ronald who says, what exposure risk is there to maintenance staff regarding UVC?
Yeah, that's a great question. I was in an air handler at the New York Stock Exchange yesterday, and the gentleman that was overseeing the filter and lamp replacement for their air handlers asked me the same thing. Number one, very important to have safety switches on all doors in all access panels on a system, because the risk of exposure is real. If you find yourself in an air handler and you, for whatever reason, need to have the lights on, you basically need to have PPE. You need to have your skin covered. You need to have a face shield, safety glasses, and keep any exposed skin covered. And in that scenario, if you're smart about it, and if you've got signage, safety switches, there really shouldn't be safety concerns. But you do need to gear up if you're going to go in and get exposed by putting on PPE and getting yourself a safety shield to cover your face.
Yeah, so Ronald, you should know that all of the air handlers should have automatic switches that de-energize the UVC system when any access panel door is opened. So typically, the risk is very low because the system will be off. The lights will not be operating when anyone is inside the air handler. If you're viewing UVC through a viewport, it's made for viewing. It will block the UV energy, and there's no hazard to looking through a viewport on an air handler. So I hope that answers your question. We have one more question. How much room do you need to install the UVC? Can they be retrofitted on like a rooftop unit, or do we need a larger or custom buildup?
No, great question. Typically, we like to be about 12 inches away from the surface of the cooling coil on the downstream side. And some smaller rooftop units really don't afford that amount of spacing. So the workaround is, in some cases, you might have to have two lamps because they're mounted closer to the coil, and you don't have that area for the energy to reflect and bounce around. But there really aren't too many air handlers, even down to small 5-ton rooftop units, that can't or won't accommodate at least one UV lamp. And for much of what we talked about today as it relates to energy savings and optimizing a system, a small unit really doesn't require a whole lot of lamps to keep that coil clean. So to answer the question, sorry for the long-winded answer there, Joel, you don't need a ton of room, and virtually every unit, even smaller rooftop units, will accommodate enough UV in order to get the job done to provide those deliverables that we talked about today.
Okay. All right, that's about all the time we have left, Joe. If we didn't get to your question, please email us at info@team-uvc.com. And as Paul and Joe noted, we're going to have a copy of this available tomorrow on the facilitiesnet.com website, and that'll be under industry webcasts. All right, Joe, you want to close us out?
Oh yeah, that's great, Joel. And Paul, thank you for helping put this together. And to everyone that attended today, really appreciate it. I hope you were able to get a couple of nuggets out of here and help make a successful pitch. And thank you again for joining and making time to learn more about UVC and HVAC systems. Thank you very much. Bye-bye.